Dear students, I am Dr. Rajiv Sapre and this is audio number 101 for you. In previous audio, we were discussing about ellipse, right? What is standard equation of ellipse? It is x square upon a square plus y square upon b square is 1. And the formula that relates a and b is b square is equal to a square into bracket 1 minus e square. This e is eccentricity and it is less than 1 in case of ellipse. In case of parabola it was equal to 1. Now when you consider this standard equation x square upon a square plus y square upon b square is 1, we have seen that this particular curve ellipse is symmetric about both x and y axis. There are 4 vertices of a ellipse. Capital A, it is coordinates of that point are small a comma 0, then a dash which is minus a comma 0, then capital B 0 b and capital B dash 0 comma minus b. These are 4 vertices. Then there is a concept of major axis and minor axis. In standard equation of ellipse, a is greater than b. So the distance between a and a dash will be 2a, right? And 2a is called major axis, 2b is called minor axis. If you consider just small a, it is semi-major axis, small b is semi-minor axis, like this. There are 2 foci and 2 directrices. Coordinates of the foci are ae comma 0 and minus ae comma 0. We are talking about standard equation of ellipse. So foci are ae comma 0 minus ae comma 0, and equations of directrices are x is equal to a upon e and x is equal to minus a upon e. Okay, so distance between foci will be 2ae and distance between directrices will be 2a upon e. Then also we talked about extent of ellipse. Okay, and what was the answer? Ellipse is closed curve, right? And it lies between the lines x is equal to plus or minus a and y is equal to plus or minus b. Then what is eccentricity of the ellipse? Okay, eccentricity formula you can easily get by the relation between b and a. That relation I told, what is that? B square is equal to a square into bracket 1 minus e square. So if you expand the bracket, it will be a square minus a square e square. So b square is equal to a square minus a square e square, and so a square e square will be a square minus b square, and so e square is equal to a square minus b square upon a square, and so it will be root of a square minus b square upon a, right? Root of a square minus b square upon a. This is the formula for eccentricity. We can easily derive it at the time whenever you need. Only thing is you have to remember b square is equal to a square into 1 minus e square. Simple calculations will lead to this formula. E will be root of a square minus b square upon a. Then we have lattice rectum. Every conic section that you will visit will have all these things, right? What is lattice rectum of ellipse? What is eccentricity? Then what is the extent of the curve? What are the coordinates of focus? If there are more than one focus, what are the coordinates of foci? Equations of directrices. All these things will be there in case of every conic section. So you should better prepare a table and remember all these formulae. So lattice rectum, you know what is a lattice rectum? It is a chord of the ellipse through its focus and perpendicular to major axis of the ellipse, right? It is a lattice rectum of the ellipse, chord through its focus and perpendicular to its major axis is the latus rectum. Now since ellipse has two foci, it has two latera recta, we can say. Plural of latus rectum is latera recta. So let LSL dash be the latus rectum of the ellipse through focus S. Since S is AE, 0, okay, the coordinates of L, when you consider, it will be suppose AE, K, because AE will remain same. Latus rectum will be parallel to y-axis, and when anything is parallel to y-axis, the x coordinate is constant, right? As it passes through AE, 0, which is focus, x coordinate of latus rectum, any point on the latus rectum when you take, it will be AE. Other coordinate, y coordinate will be different. So AE, K we take. Okay. Now L is the point on ellipse. So by the knowledge of locus, you know, whenever a point lies on the locus, it satisfies the equation of locus. So we get a square e square upon a square. I am putting AE, K in the equation of ellipse. X square upon a square plus y square upon b square is 1. So I get a square e square upon a square plus k square upon b square is 1. And when I solve this for k, what you will get, see, a square e square upon a square means a square gets cancelled. So k square upon b square is equal to 1 minus e square. And so k square will be b square into bracket 1 minus e square. But as we know, b square is equal to a square into 1 minus e square. This 1 minus e square is b square upon a square. So whenever I put k square, whenever I consider the equation k square is equal to b square into 1 minus e square, in place of 1 minus e square, I can put b square upon a square. You write down this, then you will understand easily. So what will be my k square? It will be b square into b square upon a square. Actually it was b square into 1 minus e square, but 1 minus e square is b square upon a square. So finally I get b raised to 4 upon a square. So k is plus or minus b square upon a. Okay. Since L lies in the first quadrant, k is greater than 0. Right. So k is b square upon a. K is minus b square upon a gives the y coordinate of the point L dash. Right. So the extremities of the latus rectum to the ellipse x square upon a square plus y square upon b square is 1 are AE, b square upon a and AE, minus b square upon a. So these are the extremities of the latus rectum. Okay. So length of the latus rectum will be 2b square upon a. Right. So also we can show that the extremities of the latus rectum through the focus S dash. What are coordinates of S dash? Minus AE, 0. So what will be the ends of the latus rectum which passes through S dash? It will be minus AE, b square upon a and minus AE, minus b square upon a. Right. So these are the things that we should remember about standard equation of ellipse. But this is called a horizontal ellipse. There is another ellipse that we can think about, and where a will be less than b. Here standard equation of ellipse, when you consider a is greater than b. But there is another ellipse where a is less than b. Okay. So consider the equation x square upon a square plus y square upon b square is 1, where a is less than b. This is a vertical ellipse. This is vertical ellipse. Here major axis lies along y axis and minor axis lies along x axis. Right. So you can imagine the figure. Right. Now this ellipse is also symmetrical about both the coordinate axes. and about the origin. Center of this ellipse is also origin. Instead of b square is equal to a square into 1 minus e square, here the formula will change. It will be a square is equal to, instead of b square, now left hand side is a square. A square is equal to b square into 1 minus e square. So here eccentricity will be root of b square minus a square upon b. Right? The foci are along y-axis. So there will be 0, plus or minus BE. Equations of directrices. Here directrices will be parallel to x-axis. So the equations will be y is equal to b upon e and y is equal to minus b upon e. Vertices are capital A comma 0, capital A dash minus A comma 0, B 0 comma B and B dash 0 comma minus B. Here A dash, capital A dash is 2A, it's minor axis, and B dash, that is 2B, it is major axis. A is semi-minor axis and B is semi-major axis. Lattice rectum is 2A square upon B. Instead of 2b square upon a, it will be 2a square upon b. And extremities of the lattice rectum we can calculate with the method that we have discussed. But finally outcome will be extremities of the lattice recta or latera recta are a square upon b comma be minus a square upon b comma be, then minus a square upon b comma minus be, and a square upon b comma minus be. Right? So this is the information about both the ellipses. We can make a table about all this information, and that tabular format you have to remember always, because that will help you to solve the problems. So what you do is, suppose I consider the ellipse. I will collect all these facts together that we have discussed and put in front of you. Suppose I consider the ellipse x square upon a square plus y square upon b square is 1, where a is greater than b. This is the standard ellipse. Here center is origin, vertices are plus or minus a comma 0 and 0 comma plus or minus b. Foci are plus or minus ae comma 0. Relation between a, b and e is b square is equal to a square into 1 minus e square. Eccentricity formula will be e is root of a square minus b square upon a. Equation of the axis, major axis, y is equal to 0. Minor axis, x is equal to 0. Length of the major axis 2a. Length of minor axis 2b. Equations of directrices, x is equal to plus or minus a upon e. Extremities of latera recta are ae, plus or minus b square upon a and minus ae, plus or minus b square upon a. Length of the lattice rectum is 2b square upon a. Distance between foci 2ae and distance between directrices 2a upon e. Right? So this is the information about the standard ellipse, which is actually horizontal ellipse, where major axis is along x-axis, minor axis is along y-axis. Now you consider other ellipse. As there were 4 parabolas, here there are 2 ellipses. Other equation is same. It is same, x square upon a square plus y square upon b square is 1. But the main issue here is b is greater than a. So here also center is origin, vertice is same, plus or minus a comma 0 and 0 comma plus or minus b. Foci are 0 comma plus or minus be. Relation between a, be is a square is equal to b square into bracket 1 minus e square. Eccentricity formula is e is equal to root of b square minus a square upon b. Major axis x is equal to 0. Minor axis y is equal to 0. Length of major axis 2b, length of minor axis 2a. equation of directrices y is equal to plus or minus b upon e. Then extremities of latera recta are plus or minus a square upon b comma be plus or minus a square upon b comma minus be. Length of latus rectum 2a square upon b. Distance between foci 2be and distance between directrices 2b upon e. So this is the comparison between the two ellipses. One is standard ellipse where a is greater than b, and this is another ellipse where a is less than b. In case of standard ellipse, major axis is along x-axis. In case of this ellipse, major axis is along y-axis. Accordingly, there will be changes in formulae. You have to remember these formulae because they will be useful in solving the problems. Okay, so I hope you enjoyed this audio number 101. Thank you.